Record in the cloud. And let's go. Hello, everyone, and welcome to this webinar. My name is Chris. I'll be your host tonight, and we'll be joined in a bit by Jim Sheldon, but we won't start right away. We'll give us a few minutes for everyone to turn up. While you're all turning up, let me give you a bit of the housekeeping rules. So this webinar is being recorded. We will send a link to the recording along with a follow-up email after this webinar is finished, probably tomorrow morning. So you can go and review this in your own time. We'll also put in some links or things that might come up during this session. Do feel free to introduce yourself on the chat. If you are using the chat, please make sure that you select the everyone option so that everyone can see your messages. It'd be great to find out where you're all from and who you are. Throughout the webinar, there'll be opportunities for questions. We can collect those in the Q&A feature, and then I'll make sure to ask Jim those questions at the end. So when you think of your questions, do please drop them in the Q&A feature, and then we will get to them at the end. So hi, David, Oakland, California. We've got Austin, Texas as well. So hi, Tom. It's a strong US showing today. Sweden, excellent. We've got some European participation as well. Fantastic. Great. So hello, everyone. Just for those of you who have just joined, my name is Chris, and I'll be hosting this webinar today, and we will have the talk by Jim Sheldon very shortly. So just a few housekeeping rules. This webinar is being recorded. We will make sure to send a link to the recording in an email after this webinar, so you can go review this in your own time or maybe share this with other people. There is a Q&A feature. When you think of questions through the webinar, please use the Q&A feature, and I'll make sure to ask Jim these questions at the end so that we can get the questions answered. But do put them in so you don't forget them when they come up. And also, as many of you are doing, do feel free to introduce yourself on the chat. So we have some good coverage here. We've got Ireland, Denmark, Florida. We've got Pakistan as well. This is truly an international group. Canada, Sri Lanka, Kenya. Wow. You are an international bunch. Hello to everyone. Fantastic. Okay. Right. So welcome, everyone. My name is Chris, and this webinar is being recorded. We'll send an email afterwards. Please use the Q&A feature if you have questions through this webinar, and feel free to chat. Yes, the audience is muted. Don't worry, no one can hear you talking. That's why if you want to communicate with everyone, use the chat or alternatively the Q&A feature. So I think we've probably got a good number of people have joined. So I will think we should start the webinar. So it is my great pleasure to introduce Jim Sheldon, who is a principal software engineer at Meltwater. And he's going to be giving us a talk today. So over to you, Jim.
Great, thanks, Chris. Hi, everyone. Thanks for coming. So I'll be sharing some of Meltwater's experience with these three technologies and best practices around Terraform, GitOps, and Kubernetes from our experiences in the past few years. And so hopefully you have some exposure to Terraform, Git, and Kubernetes, and hopefully this will make sense. So here's me. Nice to meet you all. I'm like Chris said, I'm a principal software engineer at Meltwater. I've been with Meltwater about 7 years now. And if you want to find me, you can find me on Twitter or GitHub. If you've never heard of Meltwater before, we are a software as a service company, and we have products around media monitoring, media outreach, social listening, social publishing and engagement, and social influencer management. So some hopefully impressive stats around our main search cluster. That's the core of our product. We have about 250 billion documents, where we're adding like 500 million or so documents a day. And our customers are executing about 4 million searches per day. So if any of that interests you, you can learn more at meltwater.com. So Meltwater, we are a global company. We have engineering offices all over the world. We're constantly growing. We've acquired, I believe, 3 companies just this year. So it's a lot to keep organized, certainly from an engineering perspective. I am near the Manchester, New Hampshire office in this map view. So yeah, we're spread out quite a bit. So I work on a team that is part of Meltwater's foundation mission. And this is our mission statement. We enable teams to accelerate without thinking too much about the infrastructure, allowing a rapid path from ideation to prototype to providing business value. So we're 2 teams. We have one in Europe and us in North America. So we provide services, documentation, example code, configuration, and training to help Meltwater teams deliver business value faster. So Meltwater engineering teams are autonomous. So they can choose to not use our services or best practices if they feel that it makes sense for them. So being a global company really drives how our teams work and how we work. We rely heavily on our engineers actually wanting to use our services and promoting them to each other through word of mouth and just spreading organically throughout all these different regions where we have offices. And so today's talk is, of course, on these 3 technologies: Terraform, which is Meltwater's infrastructure as code choice; Git, which is the source of truth in our world; and of course, we'll talk a bit about Kubernetes, how these things fit together, which is our container orchestration choice. So my team, we're responsible for managing Meltwater's AWS consolidated billing. So Meltwater teams own their own AWS accounts. So we provide example Terraform templates, modules, and examples that make it easy for them to manage those accounts as code in GitHub repositories. And then our foundation team in Europe manages a Kubernetes cluster that we use and many other Meltwater teams use. But my team's not responsible for running and operating the cluster. We're consumers of that service, just like all the other teams. So yeah, so let's talk about where we started on this journey and rewind a little bit. So here is the timestamp from the first commit to our Terraform repository almost 6 years ago. So it was around this time that Meltwater was beginning our push out of the data center and into the cloud, into AWS. And we were just getting our feet wet with infrastructure as code. So that Git repository looked something like this. I won't focus too much on this phase, but this approach didn't last very long, and we'll talk a bit why. So this was a single repository for all teams Terraform config. And there were things like modules were symlinked by a relative paths into each directory for each team. And webhooks would then trigger for every team's config, it would trigger Jenkins job that would watch just their directory and apply the config. So like I said, this didn't last very long. Teams started to really impact each other quickly. So we quickly moved towards separate Git repositories per team that looked something like this in the most simple view. So this gave teams a lot more autonomy and ownership over their, like, for example, their pull request workflows for sure. In that other repo, they'd only have one workflow that all those teams would have to follow. Modules were moved then off into a separate repository where they could be tagged and versioned appropriately. So this was a big improvement. So where they'd have AWS usually at the top level, and then whatever sub accounts they'd have, usually dev, staging, and prod. So if we then zoom in on the directory structure of what I just shared, this is what we recommend that teams start with. So we actually have a GitHub template repository that has all this structure all the scaffolding there already. So when they create a new repo for their accounts, that's what they start with, and it looks something like this. So so accounts are separated by directories, regions or AWS regions are separated by directories. The configuration is split up by configs like default. Maybe you have some VPCs, you have separate apps or projects, and those end up in their own directories, trying to keep the number of resources being managed by that state file small, so that when you are running Terraform, it's not taking many minutes, or could even 10, 20, 30 minutes. I've seen some Terraform runs go, and that really just slows things down. So we try to keep the state that's being managed in each directory fairly small. So each directory with Terraform config defines its backend in S3, and you can see here that's usually defined in the terraform.tf file, and the backend looks something like that. It'll have a bucket that's specific to the account, and then it'll have a directory structure that matches the structure in the repo. So then we have deployment pipelines that will look for these Terraform version files that would figure out which Terraform version to use when Terraform runs, usually by the tool tfenv. So this makes for a very flexible, easy to understand config for most teams to get started with. So let's talk about, so that shows one model, the one that we recommend teams start with. But let's talk about some other models that we've seen. Like I said, teams are autonomous. They constantly surprise us with what they want to do and what works best for them. So, for example, well, another solution we've seen is multiple Terraform repositories per team, one per account. So in this case, there's one for dev, one for staging, one for prod. Everything else is identical. So the big advantage here that we've seen for the teams that use this method is they get more security and control is possible. More control is possible in the different repositories. For example, teams can have more strict requirements on pull request workflows in the production repo versus either the staging or dev repos. So another option we've seen is branch-based. So this would be a single repository where there's a branch per account, where changes are promoted from one branch to the next. So this requires TF vars files. If you haven't seen them before, it's a way of specifying variables that have to be passed through the command line. So the CI pipeline has to support that, but that's pretty straightforward. So if it's a dev branch, it will look for the dev TFR, staging looks for staging, prod looks for prod. So this does a great job of reducing duplication and potential for drift between directories or even repos, like I shared before, with the trade-off being that this is a single lane road. And once you're on it, if you get it changed into dev that's not ready yet for staging, then maybe your teammate that wants to get something to staging, they are now blocked by you unless they want to do some complex cherry picking. So that's the trade-off that we've seen, but it does work for some teams. So yeah, what we just talked about is a GitOps. This is the kind of a buzzword right now, GitOps. A lot of presentations you watch want to try to define it. And I actually just watched a presentation that had a different definition of what GitOps might mean versus other presentations I watched. So there's quite the spectrum out there right now. So what's good, I think, is that recently there's been a working group formed. So if you haven't seen it, there's now a Git Ops Working Group. They've launched this website recently, opengitops.dev, and here they provide 4 principles. So the first two I totally agree with, being declarative, versioned, and immutable. For the third and fourth, I agree that they definitely improve on the first two, but I'm curious as to whether you really need to be considered to be doing GitOps if you're not doing all 4. So for my team, the best practices that we currently recommend don't cover the third principle. Everything that I've shown and I'll talk about today is all push-based. Nothing's being pulled automatically or continuously reconciled. So when I was putting this together, I started to wonder, like, why hasn't Meltwater been pushed towards adopting those third and fourth best practices yet, at least according to this working group. So that's what I'll get more into the next few slides. Another good resource on GitOps is the GitOps frequently asked questions from Weaveworks that I definitely recommend reading. So on to some reasons why I think we haven't been pushed in that direction just yet. So this is the fourth point, the fourth principle: software agents continuously observe actual system state and attempt to apply the desired state. So here, a lot of this could be argued is just good modern cloud architecture best practices, where services are designed to be fault tolerant, highly available, and self-healing. So for example, in EC2, we make heavy use of auto scaling groups with health checks. During deployment, the first instance in the new auto scaling group has to become in service before the ELB will send any traffic to it. If an instance fails checks, the auto scaling group will handle that for us. If an ELB has unhealthy hosts, we actually get alerts for that. All of our processes in EC2 have proper systemd service definitions. So I've definitely seen teams that haven't quite grasped what's available at the operating system level if they're doing things that way. And systemd is really great at making sure that your process stays running and comes back if it crashes and sends logs everywhere you expect and all that kind of thing. And maybe a controversial point that we do still use Puppet. So we have config management at the OS level. I think it could be an interesting talk on its own to talk about where config management maybe ends and GitOps and Terraform or infrastructure as code begins, where there's a gray area in there. But for us, we've decided where Puppet ends and Terraform begins is a clear line for us, and it's been working well for what we do. So now on to Kubernetes. So we make heavy use of liveness and readiness probes. Hopefully everyone is. Every team has their own namespace. They can't manipulate other namespaces. So if someone ever does anything manually, it's someone on your team that has done it. It's not someone potentially from another team that maybe did something by mistake or even intentionally. So, and the team agrees that the CD pipeline is responsible for kubectl apply. So manually running kubectl for changes is forbidden. So unless emergencies come up in production, sometimes, and you have to do a kubectl edit, then it's up to you to get that back into code and reconciled. So here's an example. These are not they're certainly software agents of some kind that are observing the state and attempting to apply the desired state, not from the code that we define, but through how we've defined the services that we're leveraging to keep an eye on things. So another point, so we use Prometheus to continuously observe our infrastructure and services. So all of our services are continuously probed with the Prometheus black box exporter, which so any kind of increased latency or failures results in an alert for us. And last one is a big one. Unexpected changes seen in a Terraform plan output in pull requests is a big deal. If we're off opening a pull request and you see something that you didn't expect, then that's kind of a drop everything. Hey, let's dig into this, understand why our running state doesn't match our desired state. And in my experience, this is very rare, and really only happens maybe once in a great while in dev environments is where it happens more often, I'd say, because it's more likely that maybe you've done something manually on a local branch, and maybe I would never be guilty of this, of course, but applying something locally, opening a pull request, and then closing the pull request and forgetting to tear it down again. that may have happened once before. So we're certainly not immune to state drifting and that kind of thing, but it's a big deal for us when it does happen, and we always come together and get a good understanding of what led to it and how to avoid it. So another one that I wanted to give its own slide is that when we have a pull request that we've merged to master, and maybe I don't know if I made it clear, but the apply will only happen on the main or master branch, the default branch. We don't do applies like from pull requests, like I think Atlantis there's a tool that will do that for you. So we don't do that. It's only once it makes it to the master branch. And our pipeline, if the Terraform apply fails, will give us the user, the engineer that merged that change will get an alert on their phone saying, hey, something's broken, go fix it. You're expected to drop what you're doing and go fix it. Because now the desired state does not match the actual state. So covering all that, are we doing GitOps? Maybe you get to decide. So I don't disagree at all with those third and fourth points. I think they definitely improve on the first two, but I'm just wanted to share some reasons why I don't think that we've been pushed in that direction just yet. So there are definitely more mature tools in Kubernetes, like Flux and Argo, for handling the pull-based continuous reconciliation. And that's great for Kubernetes. I would love to learn about other potential workflows for things outside Kubernetes. So we have teams using things like Elastic Beanstalk, ECR or ECS, static websites, all kinds of different places. Serverless is another good example. So being on a team, providing best practices and examples and what we do, we want to give teams something that they can follow for all their potential workflows, not just, oh, hey, if you're, Kubernetes is great, we can use it for a lot of things, but they're still going to be outliers, and we would definitely want to give those teams the same advantages of the teams in Kubernetes. So yeah, I'd love to talk more about that. So now that we started talking a little about Kubernetes, so let's talk about what we recommend for teams when they're getting started in Kubernetes. So previous slides, I've been talking about Terraform managing AWS infrastructure. So most teams, when they're starting with Kubernetes, will just be writing raw Kubernetes YAML. And it's up to them if they want to adopt tools like Helm or Customize or something else. Teams have full access to their namespaces, like I said. They get to decide what tools and processes work best for their applications. So this results in a very similar workflow to our separate infrastructure Terraform repository, where we can use the same kind of tooling for our pipelines. And of course, we can still use Terraform, where I just said we do expect teams to start with YAML to get familiar with Kubernetes. It is, of course, possible to use the Terraform Kubernetes provider, which our team, we love that provider. We use it quite a bit. So the Terraform Kubernetes provider, it's not explicitly recommended to other teams, but we know other teams are using it. So if you've never seen it, here is an example. Terraform on the left, YAML on the right of a snippet of a deployment could look like. So hopefully that makes sense. And so here's something a little different. So here's an example of what we see as an advantage of Terraform, where extra functionality can easily be added. So has anyone run just kubectl apply in their deployment pipelines? They've probably broken their config at least once, where kubectl apply will happily return like, hey, yeah, I applied, everything's good. But in reality, maybe you had a typo in your image, Docker image name or tag or something, and the new image can't be pulled, and it's sitting there in back off constantly trying to pull that image that doesn't exist. So that was definitely a problem we saw under with pipelines where we had started off with just running kubectl apply. So things end up in a broken state. And the only way you'll see that is then if you maybe were looking for a feature to show up in the app that doesn't appear, or maybe you ran kubectl get pods to see what the state is, and then you noticed it. So this is a way when you run kubectl rollout status on the deployment, it will help you avoid that. It can tell you, it will watch that deployment to completion. If it fails or if it times out, then that is an exit code that causes your pipeline to fail. So where we've managed used Terraform to manage some Kubernetes configurations, this is really, being able to do things like this is really helpful. Where we don't have to go and change our deployment pipeline for this. We don't have to add extra scripting. We can make a script get created by Terraform and have it executed when our deployment, or after in this case, the deployment runs, since it has a depends on there. So here's an example of what the output would look like when that runs in our pipeline. So another advantage of Terraform and Kubernetes we've seen is being able to do things like this. So here we have, so for example, in development environments where we're running infrastructure and it costs money, be it in AWS or Kubernetes, pod services, deployments, everything that it continuously runs is going to cost something. So the easier it is to destroy that infrastructure or that running processes when we're not using them, and as well as being easy to recreate when we need it again, the more likely we're actually to do it, and not just say, it's all right, it's okay, we're spending money. So as long as where I had a previous slide that showed the state file backend configuration, that file is required for this to work. You can't lose that and expect Terraform to still work. It needs to know where its state file is so that it can figure out what is running and what should be running based on your config. So if you keep that file, that in this case it's in the terraform.tf, but if you just rename, for example, that main.tf that has all the infrastructure defined in it to anything besides a .tf, Terraform won't see it, and that will effectively destroy that infrastructure or that Terraform or Kubernetes configuration. So a big issue that we saw when we first started getting into Kubernetes was, okay, now we're done running this experimental deployment and development. We want to tear it down. Well, our deployment pipeline was only set up to do kubectl apply. If you go and delete a file, a Kubernetes YAML file, and then expect kubectl apply to actually remove it, it's not going to help you with that. It won't do that because the file is not there. And even if you try to detect that when a file or YAML file was deleted, it's still not there. You need the file to be able to do kubectl delete and then pass the file name. So with Terraform, that solves it for us. By following something like this, it's by just renaming that, in this case, the main.tf, then Terraform won't see it anymore and it'll destroy that infrastructure. So that has been really helpful for us. And of course, I don't like like running kubectl delete manually or Terraform destroy, especially in production. That's pretty scary. So what it means is that we can do Terraform apply for all of these different potential workflows. We don't have to worry about anything else. Creations, modifications, destroying infrastructure, all work with the same workflow. Anything that has a Terraform provider. I mean, I focused on AWS and Kubernetes here, but Terraform has lots of different providers. We've used the Datadog provider. That's one I can think of, but there's a lot more out there. So hopefully sharing all these different workflows that have helped Terraform be so successful at Meltwater and how we feel that we're following at least some of the principles of GitOps. Hopefully that's been useful. Personally, I would love to hear, again, any other processes that other organizations are using to do that pull-based GitOps workflow in areas other than Kubernetes. Maybe it's just a cron job that you set up in your CI pipeline to run every once in a while to run a Terraform plan, for example, and then tell you, hey, something's different from what you expect to be actually running. I could see that being useful. So that is pretty much the end of what I had for everyone. And that if you're interested in what Meltwater is doing, we have an official engineering blog at underthehood.meltwater.com. We have a official Twitter account, MeltwaterENG, if you want to keep an eye on what we're doing. And like a lot of tech companies these days, we are, of course, hiring. So careers.meltwater.com, you can see all our open positions. I think almost every office, every engineering office has something listed there right now. And with that, I thank you very much. And I'm happy to answer any questions.
Great. So thank you very much, Jim. That's been super interesting. And there have been a load of questions that have turned up. So get ready. I'm going to try and group these things together because there are a couple of questions that seem to overlap. So we've got a few questions around testing of Terraform. So we have a question asking, do you allow teams to test Terraform apply? How do you test the infrastructure before creating a PR? And then we've also got questions about Terraform apply only running on master. How do you manage these things, for example, on an intermediate environment where you can run things like integration tests? So if you could tackle the question of actually testing the Terraform apply, which I think has been asked from lots of angles.
Sure. So where I said we've broken out modules into other repositories, so that is where we can run tests on the modules themselves. I know we've used something called Terra Test, and I know there's another one that I'm going to forget. There's another good Terraform module testing tool, or I don't even think it's specific to modules, but it's certainly where I see it used the most is if you're, if you are the author of a module, in which we are for a lot of things for internally, then we can do our own actual bringing up infrastructure when we're making changes to that module and verify that it's behaving the way that it should. And so apart from that, if you're a consumer of the module and you're trying to test your stuff, I mean, what's I think most teams will follow is following one of the few different workflows that I shared early on in the slides of either separate directories in one repo for different accounts, or multiple repos, different accounts, or even a branch based. So they're always trying something in a dev environment first, and then whether or not that's going to work exactly how you expected, once it goes to the next environment is the ultimate question. But it's not something that comes up, I would say, very often, where when you're doing everything as code, it's you've really reduced the potential unknowns as much as possible. So hopefully that answers the question.
Yeah, thanks. So following up on that, we've got another set of questions, which I guess is a layer higher, and that is around, do you have any guardrails or security checks in place on the code? So are you scanning or testing your code prior to actually getting to the stage of applying it?
Yeah, so nothing recommended to teams right now. We are evaluating some third-party solutions right now to do exactly that, to say, hey, here's add this command to your pipeline, and this will give you better insight into potential security issues. We do have a dedicated security team that does a lot of work directly with teams, so they'll do things around penetration testing, both externally and internally. They'll help teams review, not specific to Terraform or Kubernetes, they'll help them review their code itself and scan for issues within their actual applications. But yeah, so they're constantly running scanners and finding vulnerabilities and communicating with teams. So yeah, we have a lot of potential progress to make there, I think. But that's where we are right now.
Very good. And then we also had a question that came up from, let me just find it. It's in the main chat, which is regarding the difference of opinion on continuously reconcile. Is there potential for mistakes as your team grows rapidly? Wouldn't the reconciliation capability be useful at that point?
Absolutely. And I've just had to deal with this the last couple of days. How can I explain? I had a good example of this where, I found something in one of our deployments that I made a completely unrelated change, and the deployment failed because it was a typo that would only have been uncovered when the deployment actually ran. So that was definitely a case that continuous reconciliation would have helped. So I agree, like that, having some continuous feedback on what you've defined your running infrastructure to look like and versus what it actually looks like. I completely agree that's a good idea. I'm still very interested in how to actually do that apart from the big tools that everyone recommends, which is Flux and Argo, which certainly we do a lot in Kubernetes, but we do a lot outside of Kubernetes. Serverless is probably the biggest example in AWS Lambda. We have a lot of teams doing things in there where I would hope that there could be similar workflows that can be followed. And again, maybe it's just running something in a cron. Maybe that's enough.
If it makes sense. To change tack a bit, we have a question here about what are your thoughts on creating an abstraction layer between the devs and the Terraform code?
That's a good question, yeah, because not everyone is thrilled about learning Terraform. We think it's a pretty low barrier to ask of teams, and it doesn't come up too often. The teams are like, yeah, we don't want to deal with this. We want to focus on writing this or that, and someone else deals with it. So there's not much expectation of that kind of mindset in Meltwater. There's a very strong ownership mentality that your team is you own your stuff. You're on call for your stuff. So most of them will say, okay, show me how you recommend to handle the infrastructure side of it, and the definitions of how to run our stuff. But there are teams who really like the CDK, for example, where they can write, I believe they can write in JavaScript in other languages for defining AWS infrastructure. Some teams have used CloudFormation, and that works well for them. I'm trying to think if there are others. But yeah, as far as an abstraction layer, so they wouldn't have to use Terraform. I think right now Terraform is the entry level for us. We like I said, we have training materials that so we don't expect teams to just go off on their own and learn it. We will do enablements with teams, actually schedule meetings and set aside time, and we have some Terraform learning material that we've put up in Katacoda that's public that will help teams get leveled up to where they're comfortable doing Terraform changes. I was just working with one of our recent acquisitions a couple of days ago, where they haven't done anything in Terraform before, and now they're just getting started.
Very good. And then I think just as you were asking that, there was a question about opinions on Terraform CDK over HCL, and I guess things are about support, testing, and so on.
So, I mean, I have strong opinions. I mean, we really like Terraform. I mean, it's certainly not perfect. It's improved so much now that it's on version 1. There was definitely a lot of pain in the previous years, like going from before 0.12. 0.12 was the big breaking change. You actually had to do a decent amount of manual commands to update, and there were things that could break that were again manual to fix. So that was pretty painful. But since then, it's been pretty smooth. Yeah, so it comes down to a team's comfort level. I think it's important that I know there are organizations out there that you have site reliability engineers, you have DevOps engineers, you have a team that's like, okay, we're going to make the infrastructure, we're going to define the pipelines the teams are going to use to deploy, and I'm sure that works in a lot of cases. It definitely wouldn't work for us. I could say for sure, because we're so spread out and there's just so many different approaches. Like we have the team running our search cluster is a big team. They're very, very competent, have a lot of experience. There's no way we're going to do things better for them than they will do for themselves. So all we can do is we have this idea of like we're trying to provide the best solutions for like 80%, the 80% use case. So if we can get 80% of applications and teams following our best practices, like that's successful for us. We know we'll never get to 100. There's always going to be 10-20% of teams or processes and things that we can't quite fit, and that's fine. Luckily, AWS is the services that AWS provides are amazing. Like there's almost always a service that teams can spin up themselves. Like teams could run their own Kubernetes cluster. They haven't yet, that I'm aware of, through AWS. They certainly run their own databases. They can run their own CI pipelines and things like cloud code. What's it called? Code deploy. Code. I forget. We also, I haven't mentioned it yet, but we also manage and run the CI/CD platform that Meltwater teams use. It's Drone. If anyone hasn't heard of it, it's drone.io is the site. So it's open source. So that's one of our applications, and everything that we provide as best practices and workflows will obviously provide have an example drone pipeline configuration that teams can hopefully just kind of drop into place, and it'll do what they need.
Very cool. We have a few questions just to change tack a bit around the Kubernetes setup. So there's a question about whether you're using self-hosted or using a managed Kubernetes, and then how you ensure the multi-tenancy in the clusters. You mentioned namespace separation, but how far does that go?
Yeah, no, those are good questions. Again, I'm not on the team that runs the cluster. I just happen to be on, they're like our sister team. So they are 100% owners of it. So I know that they use Kops to manage the cluster. So it's not a managed service. And as far as multi-tenancy, I know they have some things in place, but I'm not a good person to ask.
Yeah, fair enough. I think we've got time for a couple more questions. So one here asking, have you used additional Terraform tooling such as TerraGrunt or Terraform tests such as TerraTests?
Yeah, I think I mentioned TerraTest earlier. TerraGrunt, I haven't used it in a long time, and I forget why we used it at one point. So I'm not up to speed on that. But yeah, TerraTest is definitely a nice way to write tests where that will actually bring up infrastructure, real infrastructure, and verify that what you expected to have come up and actually did. So we definitely have used that, and it's worked well. I think that answers it.
Okay, very good. I think we have a couple of other questions, although they're mainly kind of duplicates, or I think we've covered most of them. So yeah, I would say in that case, unless there's any last minute additional questions anyone wants to ask. There was a quick question following up on the drone bits. Do you use the enterprise version of drone, or are you running it yourselves?
We are running it ourselves, and we're enterprise customers. So there's a cloud.drone.io that's free for open source repositories. I don't think they have a hosted private offering that I'm aware of. I think if you're an enterprise customer, you're running it in your own infrastructure like we are. But yeah, we've been running that for 3-4 years almost. So that's another success story for us. It's been great.
Yep. And I think we've got one last question on the chat. So you mentioned earlier about all of the different strategies you have of managing different environments with various Git repository structures. But how do you actually ensure consistency and avoid drift other than being very careful?
It's a huge concern. It is. And it's a trade-off of, do you make the workflow enforce it or not? And in our experience, enforcing it always slows down development to a point that it's not worth it. So in our experience, so for us, for example, I'd like to see us do more with branching, but most of our team isn't comfortable with that. So we do end up doing things in a directory separation. So I will find things sometimes that haven't come over from dev to prod, for example, correctly, and there's differences. So again, it's a constant feedback loop of, hey, and education to the people in your team to be like, hey, this doesn't look the way it should. It looks like this changes to make it over quite right, and then people will get better at it over time, but no one's going to ever get perfect at it. So we could certainly be doing the safest potential workflow is, I think, branch based, because there's no chance that you're going to miss files or anything. Whatever you open in a pull request from one branch to another, it's everything's coming over for the trip. But yeah, the separate directories, separate repos, it's a matter of getting good at using diff. And I will say something that definitely helps is trying to abstract away and compartmentalize all configuration into modules. So if you can standardize configs into modules, which a lot of our stuff can be, then the module, most of the complexity goes into the module. So you can be iterating, you can be making hundreds of lines of changes in the module, but then your dev to prod, for example, change could be just the version change on the module reference. So that is a way to reduce the chances of things being out of sync.
Very good. Cool. So thank you very much, Jim, and thank you very much everyone for your questions and your engagement throughout this webinar. As I mentioned at the start, we will be sending a link to the recording of this video once it's processed. That'll be tomorrow morning. So you should all get that in your inboxes. We'll also add some additional links that might be relevant into that email as well, so you have all of the context you need. Just as a quick plug, we have another webinar next week where we'll be looking at benchmarking DevOps teams based on 1,800 teams that have been consulted, looking at how DevOps practices differ between the different teams and what kind of the actual trends in the industry are. So I think that'll also be interesting if that is something that you are into on that front. But other than that, once again, thank you to Jim, and I wish you all a great day or evening, depending on where you are in the world. So thank you very much, everyone.
Thanks, Chris. Thanks, everyone.
Bye.